The year 2026 has officially become the year of the humanoid. For decades, we watched science fiction movies and wondered when the machines would finally walk among us. We saw the clunky prototypes of the early 2000s and the viral stunt videos of the 2010s. But something shifted in just the last few months. We have moved past the era of novelty. We are no longer looking at experiments. We are looking at employees. Across the globe, from the tech hubs of Hangzhou to the industrial parks of Boston, a hardware arms race is reaching a fever pitch. Humanoid robots are no longer just walking. They are sprinting, jumping, and performing tasks with a level of precision that challenges human capability. Today, in part 1 of our deep dive, we explore the mechanical mastery behind the Unitree H2 and the industrial evolution of Boston Dynamics Atlas. Let's start with the video that sent shockwaves through the robotics community. The debut of the Unitree H2. Unitree has long been known as the Xiaomi of robotics, delivering high-performance hardware at a fraction of the cost of Western competitors. But with the H2, they aren't just competing on price. They are competing on pure, raw power. Standing approximately 180 centimeters tall, about 6 feet, and weighing in at 70 kilograms, the H2 possesses the exact proportions of an athletic human male, but its performance is anything but average. In recent training footage, we saw the H2 executing flying kicks that leave the ground with terrifying speed and landing backflips with the stability of an Olympic gymnast. How is this possible? It comes down to the joints. The H2 is equipped with 31 degrees of freedom. Its shoulders alone have 12 joints, allowing it to move its arms with a range of motion that exceeds most humans. But the real star is the torque. The H2's custom-designed actuators deliver up to 360 Newton-meters of torque. This is the explosive power that allows it to snap into an attack state or recover its balance instantly after a high-impact collision. When you watch the H2 strike a heavy sandbag, you aren't seeing a tin man moving stiffly. You are seeing a coordinated fluid machine that transitions from one movement to the next without a millisecond of hesitation. While the H2 is the high-performance flagship, Unitree's G1 model is the one bringing humanoids to the masses. The G1, often referred to as Coid, represents the first time a truly capable humanoid has been priced for the commercial market, ranging from $18,000 to over $100,000 depending on the specs. We recently saw the G1 appear on live television, sitting on a panel and discussing the AI economy. But its mechanical specs are what make it a commercial threat. At 77 pounds, it is light enough to be portable, but strong enough to perform martial arts routines and complex dance moves. It features 23 degrees of freedom and is designed with a foldable frame, making it easy to transport. This is the robot that is currently being shipped to research labs and early adopter businesses across the United States. It proves that the supply chain for humanoids is no longer a dream. It is a functioning reality. However, across the ocean, the legendary Boston Dynamics is taking a very different approach. At CES 2026, they unveiled the newest generation of the Electric Atlas. If Unitree is building the athlete, Boston Dynamics is building the ultimate factory worker. The new Atlas has moved away from the bulky hydraulic systems of the past. It is now 100% electric, slim, and incredibly eerie in its movement. It features a unique design philosophy. Why move like a human when you can move better? The new Atlas has fully rotational joints, meaning it can twist its torso 360 degrees and rotate its limbs in ways that would break a human spine. This superhuman range of motion allows it to navigate cramped factory floors and move heavy objects without ever having to turn its entire body around. Reliability is the key word here. Boston Dynamics product leads have stated that the new Atlas is designed for 24/7 industrial use. They've simplified the internal mechanics to use only 2 unique types of actuators across the entire body. This means that if a robot breaks down in a warehouse, a technician can swap out a limb in under 5 minutes. This isn't a robot designed for a YouTube video. It's a robot designed for a Hyundai assembly. In part 1, we explored the mechanical marvels, the metal, the motors, and the torque that allow robots like the Unitree H2 and Boston Dynamics Atlas to move with superhuman agility. But as any engineer will tell you, a body without a brain is just an expensive statue. The true revolution of 2026 isn't just that robots can walk, it's that they are starting to think. we have entered the era of physical AI. For years, artificial intelligence was trapped inside our screens, generating text and images. Now, it has been given a physical form. The massive breakthroughs we saw in large language models like GPT and Gemini have been adapted into vision language action models. These models allow a robot to look at a cluttered workbench, understand a verbal command like, "Clean up this mess," and autonomously decide which object to pick up first, how much pressure to apply to a glass bottle versus a metal wrench, and where to place them. They are no longer executing rigid lines of code. They are accomplishing missions. The biggest headline in the brain race is the partnership between Boston Dynamics and Google DeepMind. At CES 2026, it was officially announced that the new electric Atlas is being powered by a specialized version of Gemini Robotics AI. This is a game changer. By integrating Gemini, Atlas doesn't just see pixels. It perceives semantic meaning. If an Atlas robot is walking through a factory and encounters an unexpected spill or a fallen box, it doesn't freeze or wait for a human to reboot it. It reasons through the obstacle. It can communicate with other robots in the fleet, sharing data in real time. If one robot learns a more efficient way to sort a specific type of automotive part, that knowledge is instantly uploaded to the cloud and downloaded by every other Atlas robot on the planet. We aren't just building individual machines. We are building a collective, hive mind workforce that improves every single second it is in operation. But how do we teach a robot the nuance of human touch? The answer lies in a surprising piece of consumer tech: the Apple Vision Pro. In 2026, teleoperation has become the primary method for training humanoid AI. Across the world, professional robot trainers are putting on mixed reality headsets and possessing these machines. Through the Vision Pro's high-resolution cameras and precise hand tracking, a human in an office in New York can control a Unitree robot in a warehouse in Shanghai. The human feels the resistance through haptic gloves, and the robot mirrors every finger movement with millisecond latency. Every hour a human spends teleoperating a robot is recorded as high-quality training data. This is called imitation learning. The AI watches the human, learns the subtle wrist flick needed to turn a screwdriver, or the gentle grip required to handle a fragile component. And eventually, the training wheels come off. The robot becomes autonomous. We are essentially using the collective wisdom of human workers to program the future of labor without writing a single line of traditional code. The financial world has taken notice. Humanoid robotics is no longer a speculative moonshot. It is a blue-chip industry. Unitree Robotics is currently moving toward a massive IPO on the Shanghai Star Market, with a valuation expected to hit $7 billion. This valuation is backed by tech titans like Alibaba, Tencent, and China Mobile. Why the sudden influx of cash? Because the math finally makes sense. With the Unitree G1 starting at under $20,000, the payback period for a company to replace a human in a dangerous or repetitive role has dropped from 10 years to less than 2. In the United States, distributors like RoboStore are already shipping these units to research labs, hospitals, and logistics centers. We are seeing the birth of the robot-as-a-service model, where companies can lease a humanoid workforce just as easily as they lease a fleet of trucks. As we look at the footage of the G1 named Coid on CNBC, or the Atlas robots shipping to Hyundai plants, one thing is clear: the transition has begun. We are moving from a world of isolated automation to one of shared autonomy. These robots are not here to replace the human spirit. They are here to liberate it from the dull, dirty, and dangerous. The hardware is superhuman.